projects actually represent the collaboration and commitment which is needed to address some of the challenges that from our time as the deployment of renewable energies, as all of you may know. During this webinar, we will hear valuable insights coming from these three innovation projects, EU-funded projects in this case. We will first start with Stefania on behalf of Carbo4Power project. After that, Fabian will represent FYBERGY. And last, we will have Marta telling us the details of the challenges and outcomes that MAREWIND has achieved so far. Our speakers will share their experiences, challenge faced, and significant outcomes from each of the projects. And the presentation are not meant only to be informative, but also inspiring, as we will witness the impact of novel technologies that are enhancing the landscape of science, technology, and innovation. We also are glad to introduce in this webinar the MAREWIND Community of Practice, which we want to build a space for knowledge sharing. Today we present this community. We open the doors to all of you to a network that aim to bring together all the stakeholders from the value chain, from the maritime and wind energy sectors. Last but not least, we will invite you to actively participate in an open discussion. We strongly encourage you to share through the chat your questions, thoughts, experiences during all the event so that we can address them during this open discussion. We will see, but in case we see that the number of questions is difficult to be addressed, all of them, we will give priority to those ones which have the most likes. So I encourage you to like the questions that you find interesting so that we can prioritize them. Okay, let's start. Let's initiate these presentations. As I mentioned, let's start with Stefania Termine. She is a material scientist with a master in material science and technology. She's currently working on the growth of carbon-based nanomaterials with CVD method, as well as CVD functionalization of carbon fibers with CNTs and epoxy-based composite manufacturing through vacuum infusion process. Furthermore, she's experienced in the electromechanical response and self-sensing abilities of carbon-based CFRPs through the electrical resistance change method. So yes, Stefania, the floor is yours, so you can take control of the presentation, I assume. And of course, you can start whenever you feel like.
Thank you, Francisco, for the presentation. I will also like to welcome you all. So as Francisco mentioned, we will be presenting Carbo4Power project. So yes, here I am. So Carbo4Power project stands for a new generation of offshore turbine blades with intelligent architecture of hybrid, nano-enabled multi-materials via advanced manufacturing. The project is a topic of NMBP 31 on 2020 under materials for offshore energy. Is a project with a duration of 48 months and the funding of 7 million. We are 18 partners, and the coordinator is Professor Kostas Charitidis from National Technical University of Athens. Here you can see all of our 18 partners that are involved in the project. from which 10 are RTOs, 8 are SMEs, and we are from 9 European countries. Here in the next slide, here are the main partner roles that they are involved in the implementation of the project. The first column are the partners that are involved in material development, then in the design and the simulation, then intermediate testing, the manufacturing of our demonstrators. We also have structural health monitoring and Internet of Things. We're also investigating the sustainability aspects of our developments. And of course, we have dissemination, communication, and exploitation activities. Here you can see the main concept of Carbo4Power project. This is dealing with robust new material architectures, hybrid nanoengineered multi-materials developments that present tailored diverse functionalities. These materials will be used as feedstock for composites, adhesives, and coatings manufacturing technologies for offshore energy applications. And all of the activities are also supported by multi-scaled modeling and design, as well as topology optimization and data analytics. Here you can see the project targets based on the concept presented. Is the lightweighting, the high strength multifunctional materials that are needed to have increased operational performance and durability, while having reduction of cost in the energy production, maintenance, and environmental impact. These composites developed are based on also dynamic thermosets that present inherent recyclability and repellability. And of course, also we have the aspect of the multifunctional and enabled coatings in order to have improved turbine protection. Furthermore, there is also the target of new blade segmentation design through the multi-material composite technologies, and also investigating the recycling based on this segmentation. So the main aspect is to open new pathways of composite manufacturing through multiple processing cycles and exploring the valorization opportunities in the offshore energy sector. Here you can see more specifically the specific objectives that there have been foreseen for this project. The two specific objectives, the first two, are dealing with the material production and investigation. The other two are with the design and the segmentation as previously presented, and the manufacturing technologies. And also this is included in the joining of these segments. Furthermore, for specific objectives 6 and 7, structural health monitoring and digital technologies are investigated. And then we have a specific 8 and specific objective 9, which is dealing with an investigation of testing campaign of those materials from the development to the intermediate level, and reducing the environmental impact. Also, there is the investigation for the recycling and repairability of those materials. And the last specific objective is to ensure the dissemination and exploitation of those technologies. So the work plan is divided in 3 phases, and also we have horizontal activities. In Carbo4Power project, we have been implementing the work for 3 years. So we have finalized phase 1 and almost finalizing phase 2. And then in the last year of the project, we are on phase 3, and the horizontal activities presented are throughout the duration of the project. So now moving on to the main key results after the 3 years of the project. As presented, we're working on the development of 3 arresing for offshore applications, which presents reprocessing, repairing, and recycling capabilities. At this stage, the formulations have been developed for the blades manufacturing processes. Then regarding the reinforcements, the surface functionalization has been investigated and performed through nano-enhanced carbon-based sizing or the carbon fibers, which then will be used for the manufacturing of the blades. We have developed novel non-intrusive quantum sensors for structural health monitoring and also other types of sensing as pressure, temperature, humidity through their implementation. And we have materials that present functional capabilities such as resistive heaters for active de-icing on the wind turbine blades. On the next slide, also, the nanomaterials will be used to develop functional prepregs for lightning strike protection. These have been achieved, and as well as on the material development is the adhesive joints that respond to demand capabilities like debonding on demand, as well as exploring the recycling of wind turbine blades to reclaim glass fibers to make functional graded adhesive carriers. Then we're dealing with coatings and their multifunctionality. So there is low surface energy coatings that they have been explored and achieved. Also, drag reduction riblets in the surface of the blades, and also erosion protection coatings for the case of the wind turbine blades. Then also we have finalized the simulation activities, and as you can see, we're investigating a lot of simulations and also designs where for the topology of the sensors or the heaters, real scale simulation, analysis of the bonding joints, and of course, the design of the scale down demonstrators. Right now, as previously mentioned, we are by the end of phase 2, where we are in the intermediate level testing. And so the main highlights from these activities is that we have tested and developed the new assembly and disassembly strategies for modular wind turbine blades. And we are now in environmental testing of the developed coatings for the lead erosion testing of the wind turbine blades, and for the active de-icing in a wind icing wind tunnel, and also, of course, the functionality of anti-icing coatings. Furthermore, there is also the aerodynamic testing of microstructure surfaces with the riblets development. Then we're in the stage where we are manufacturing our demonstrators. We're using advanced manufacturing processes such as AFP and the Madras line for the tidal blade. So we'll have one scaled down demonstrator, which will be modular for the wind turbine blade manufactured by AFP and infusion, while for the tidal blades, 2 demonstrators are investigated. One that will be truncated in scale 1, and one that is scaled down 1 to 2, and is a one-shot infusion for the manufacturing. So the expected impact for these developments is to achieve operational and maintenance cost reduction by 50%, to reduce the levelized cost of energy by 40%, and the environmental impact by 35%. Then after the finalization of the project, will run for 1 year, is to investigate the upscaling of the selected material composition for real scale manufacturing of turbine blades, of course with support with computational activities. application and validation of the functional coatings at the real scale, and the testing of those in real scale. Of course, also the evaluation of our structural health monitoring with quantum non-resistive sensors and their connection with the Internet of Things and machine learning. Of course, the application of repair technologies that are being investigated, and also see if these materials can also be applied in different sectors such as automotive, aerospace, and construction. So thank you for your attention.
So thank you, Stefania, for your presentation. I think it was very, very clear for our attendees. Okay, so now let's skip to the next presentation, which will be FYBERGY project. With us is Fabian Reichesner. He is mechanical engineer in ABG. He has been working in the field of sustainable composite material and its recycling for several years now, and he is the communication and dissemination manager of FYBERGY project. Fabian, if you can take control of the presentation, and you can start as you want.
Thanks very much, Francisco. And I would like to welcome you on behalf of the FYBERGY project. In the next few minutes, I'll give you a brief overview over the FYBERGY project and our results so far. So FYBERGY is the development, engineering, production, and lifecycle management of improved fiber-based material solution for structural and functional components of large offshore wind energy and tidal power platforms. The main goals of FYBERGY is to enable the extensive use of fiber-reinforced polymers and the structure of next generation of large offshore platforms for wind power platforms, but also tidal power platforms. The project will or has developed and qualified FRP materials for offshore applications, elaborated new design procedures and guidelines, and generated efficient production technologies, monitoring methodologies, and we validated and demonstrated this in a software analysis tool, but also with 3 different demonstrators. Why do we focus so much on the use of FRP? Obviously, the better immunity to corrosion, but also the superior fatigue properties compared to conventional materials make an optimal bring optimal properties for the use in offshore maritime applications. Unfortunately, currently we are having a lack of design and also certification guidelines. So this is why we also focus on that part in the project. To ensure industrial relevance of the project outcomes, the different activities focused on the 2 promising offshore energy concepts, which I will show in a minute. And then the different technologies we developed have been demonstrated by using simulation techniques, but also in the prototype and real scale demonstrators. We also conducted different LCA studies to calculate the ecological impact of the demonstrators in regard to the conventional ones. So the consortium consists of 12 different funded partners. We have concept developers, it's Enerocean and Titec. We have 2 composite shipyards, IX Blue, they're now called Exhale and Tuco. We have a classification society on board, Bureau Veritas. We have 3 research centers, 2 engineering offices. We have a company working on a dry painting material, and we have an association, the Association of Reinforced Plastics, the ABK in Germany, where I'm working at. So the FYBERGY community consists of a few different groups. And as you can see here on this board, we included also non-funded partners to showcase our industrial relevance. We have a market analysis and concept group. We have a group focusing on materials for the offshore application. We have a group focusing on the engineering and the tools we're using. Then we're having the hands-on, the shipyards working on manufacturing and production technologies. And then, as I mentioned, we also calculated the ecological impact. So we have a life cycle and recycling two groups. So let's have a look at the two demonstrators we looked at. So this is the W2Power. W2Power is a twin semi-submersible platform developed by the company Ocean, which hosts two wind turbines and is currently deployed in a prototype scale in the Canary Islands. On a real scale, it can enable 12 megawatts on one simple floating platform. And this concept is currently one of the most advanced multi-wind turbine designs, and the only one with a prototype of that scale deployed in the sea. Additionally, it's also one of the most promising concept with an expected LCOE reduction of 20%, and this was calculated in another project called DemoWind. The other concept we targeted was this tidal power plant made from Titech. The innovation here is the turnable Titech. So as you can see in the picture, the turret with the tidal can rotate, so it can use the flow of water in both direction, and through this rotating turret enables an optimal bidirectional functionality. And with that, we can utilize 60% of the streams flowing back as well. The cost of the 20 megawatt turbine will not be larger than the systems planned today, but the small increase in the turret cost is balanced out to a simpler turbine design, and the estimate from Titech was in a range between 45 and 75 euro per megawatt hour. So looking at the validation demonstration plan, we divided it into three tiers. So one with a rather lower scale, the small scale experimental campaign with mechanical characterization tests, fatigue performance tests, the performance of the dry coating on a rather low TRL level. So by the research centers, they try to select the correct materials. On the second tier, on the middle to large scale tests with a higher TRL, we checked for once the fatigue test of the connections, but we also tried to assess the FRP connections with other regards. We checked the performance of the multifunctional materials and then the open sea trials of the prototype. Tier 3 is the highest TRL. Here we're talking about real scale demonstrators. And so for once we built one of the columns from the platform in a real scale, and also the CAE medal of the W2Power concept was tested in real scale. Okay, let's have a quick look at the main achievements so far. Most of the deliverables are public, and they can be assessed through the open access repository from FYBERGY, and also through the website. You can find it easily in the internet. So we started with the market analysis and the quality benefits or cost benefit analysis. We checked, as I mentioned, different FRP materials and the fatigue performance of those composites, as well as the connections from the FRP demonstrators to the metal platform, for example. So here we assessed all the different connections possible. And then we did a fatigue assessment, also an aero hydro servoelastic solver for molten wind turbines. We developed a structural digital twin also of the W2 power. In work package 4, we focused more on applicable standards and certifications, as well as the redesign of both demonstrators in composite material. So we developed the concept further. And then in work package 6, we have the mid to large scale tests on dry coatings and the connections, but also on the real scale demonstrators, which I will show now. So here you can see, the FYBERGY consortium very happy because we got to visit the W2 Power in the Canary Islands. We hosted a progress meeting there, and you can see in front the tower, which was built in FYBERGY, excuse me, out of composite materials. So on the picture on the right, you can see the two towers in steel, which we replaced in carbon fiber reinforced polymer. The platform with the new composite towers is currently deployed in the Canary Islands. So we're having the 3-month open sea trials of our developed demonstrators at the moment. And what we're also testing on during this sea trials is the structural health monitoring. So we implemented different sensors in the manufactured towers to assess the fatigue and damage tolerances of the material throughout the deployment at the sea. So all of the stress from the wind and the tides and the waves, we will try to assess through those sensors. And through the digital twin we've developed, we can use the data we gather from the sensors and see how the simulation of the digital twin reacts if we can correlate those data, if the digital and the real model behave similar as expected. So another demonstrator we've built was this real scale column D. So you can see in the red square on the picture on the left, the column we've rebuilt in over 5 meters of size in fiber reinforced polymers. So here we could demonstrate quite successfully that those manufacturing technologies also work in very large scale applications. And another demonstrator we've developed was this turbine housing from Titech. So initially it was built in metal, in steel, but here we redesigned the turbine housing in FRP materials, and then Inegi did the production of this turbine housing. Here you can see how it looks finished. So with the two flanges here, the black ones, you can open the housing and place the turret inside. And yeah, that's the demonstrator. And then let's have a brief look at our impact. So we are looking at an OPEX reduction of around 30%. We're looking of an increase in operating life of 0.5%, but this goal is very, very hard to estimate being so far in the future, we can't really predict how the materials behave. Due to the superior fatigue performance, we usually hope to increase the operating life more than 0.5%. And through the structural health monitoring and the digital twin, we're hoping to get an estimation on this rather soon. And then we're also expecting environmental reduction of the environmental impact of around 35%. This would be it from the FYBERGY project. I hope I could give you a quick overview of our goals and also results by now. So thank you very much for your attention.
Okay, thank you, Fabian, for this presentation. It was really interesting. Now let's keep to the MAREWIND project. Okay, for the MAREWIND project, I'm glad to present you Marta Mateo. Marta, she's coordinator of the MAREWIND project. Marta studied the Master of Science in Chemical Engineering. She's EU project coordinator in the Technological Center Lurederra, which carries out research and applied technological development activities in the field of nanotechnology, new materials, and advanced environment solutions. She has 19 years expertise in the field of environmental technologies, new materials, and circular economy. And her research activity focuses I mean, she's in charge of several research and national projects and European projects in the 5th, 6th, 7th framework program, Horizon 2020 and Horizon Europe. So Marta, the floor is yours. You can take control of the presentation.
Yeah, I do so. Thank you. Thank you very much, Francisco. Good morning, all of you, and welcome to this webinar. Thank you all for your attending this webinar today. Okay, I'm going to talk about MAREWIND. MAREWIND is a project focused on material solutions for cost reduction and extended service life of wind offshore facilities. It is a project funded through the Horizon 2020 program of the European Commission, and it's focused on the topic of industrial sustainability and materials for offshore energy. We have been working on this project since December 2020. We are 17 partners from 7 different countries in the European Union, and we are working in different phases of the value chain. And this is a project with a total budget of almost 8 million euros, and is coordinated by the Technological Center Lurederra, which is a research center located in the north of Spain. When you receive this presentation, and also if you enter on the web of the project, of MAREWIND project, you can see a very short video which briefly explain what the project consists on. So I think it's not worthy to put it now. All of us in this forum today are aware of the importance and challenge of offshore wind energy. But I would like to point the focus on the challenge related with the damage on materials and coatings due to the hardness of the offshore facilities. So due to the wetness, the UV radiation, due to the abrasion, erosion, and corrosion. And also due to the lack of predictive modeling and monitoring system in some cases, and also in addition to the expected waste quantities. In this context, the MAREWIND project focuses on solving current challenges related to the materials, improving the durability, the recyclability, the operation, and reducing the maintenance of offshore wind facilities and installation. To achieve this, different partners, different agents participate in the project throughout, as mentioned before, throughout all the value chains. We are different research partners and industrial partners who are working on improving materials and coatings, monitoring and prediction, manufacturing some elements, validating and testing. And also we have partners on supporting activities, on important activities such as standardization, dissemination, and exploitation. The impact of the project will be quantified according to improvements in operation and maintenance of facilities, according to increased durability of materials. We are focused on improvement of corrosion protective coatings, of improvement durability of structural concrete, also the durability of anti-fouling coatings and the durability of anti-erosion blade paints. We will also quantify impacts and results according to cost reduction due to these improvements, and also the reduction of the environmental impact is expected by 35%. We will also quantify the reduction of CO2 emissions through the life cycle assessment activities in the project. Here I'm trying to show all of you some important results we have obtained up to now in the project. These results are related to the improvement on corrosion in metallic elements. We can see here images on the easy to apply coating, and we can also see substantial anti-corrosion improvements in metal elements. You can see the image of different fastening elements who has been treated and are comparing in the slide with other fastening elements which were not treated, and we have obtained good hours with results on corrosion resistance. We can also see here in this slide improvements on anti-fouling coatings on metallic and polymer samples. These samples up to now has been tested on Canary Island ocean platform, and we can check the improvements visually. It should also be noted that these coatings are free of biocides, so this is an issue of great importance in circular economy in the blue sector. In the project, in MAREWIND project, we are also working on 4th generation anti-erosion coatings for blades and for increasing the durability of the blades. Thus, we are also improving the use of resource and the waste management of this important element on the wind farms. Also, we are working on different kind of concretes, on different concretes developments. We are improving the resistance and durability. Different floating prototypes have been built and are going to be tested in Italy and also in Spain, in the port of Gijón. And up to now, the durability and mechanical operation has been improved, but it's going to be the check also, in addition to the sensors developed in the project. Also, concrete based on activated alkali materials and the dimension and BEV sensors has been produced and will be tested in the Italian facilities. We have also worked in the project in different improvements on the blades. We have worked with reinforcing the resin with silica nanoparticles. We have also worked on the manufacturing processes, and we have produced two 5-meter prototypes, and as there has been selected the process and material for 13-meter prototypes. But I would like to say that the most important results, the optimal results had been obtained, the most promising results had been obtained in terms of innovation of the blades according to recycling processes. And also we have results up to now according to monitoring. Important advances has been done in the integration of the fiber optic sensor in cements and in the materials of blades on laboratory scale. And in addition, digital imaging techniques and thermographic analysis have been demonstrated on laboratory scale, and they are able to measure under working condition. And specifically, I would like to highlight the following results up to now, with the potential to contribute in the future to the impacts mentioned before. So we can say that anti-fouling coated samples show significant delay in fouling accumulation. This result has been partially obtained in Canary Island after the access of the last 2 years. Anti-corrosion coatings has been validated with no corrosion damage for more than 4,200 in cycling test exposure, with you can see in the slide the hours of UV exposure, the salt spray, and the freezing based on the issue mentioned there. Ultra high performance concrete presents 33 reduction in cement using comparing to the standard. Durability test according to the standard show after 1 year of exposure negligible corrosion rate and extremely high chloride penetration resistance, which is important in this case, and also freeze and thaw resistance test reflected high durability performance at 200 cycles. And the integrated sensor has been successfully demonstrated in lab scale in concrete and blades. And as mentioned before, digital images correlation and thermographic analysis has been used for full field measuring techniques on wind blade working conditions. So, as conclusions of the project up to now, we can say that among the results obtained in MAREWIND, it's worth mentioning the following, which will impact directly on the sustainability and on the reduction of operation and maintaining cost. And these are the anti-fouling coatings with significant delay in fouling accumulation after several months in the sea. Also, anti-corrosion coatings, the resistance achieved in the laboratory testing would correspond to the highest corrosivity category, implying extreme resistance for more than 25 years. Easy and direct application of the coating by a spray gun has been demonstrated, and the production of 100 liters is envisaged to validate the upscaling. And according to the concrete, the ultra-high performance concrete developed presents a more sustainable solution than the standard ultra-high performance concrete, and shows 19% durability improvement compared to the standard T60 at the same age. Finally, also successful testing of sensors and on concrete and composites for blades has been achieved in the project. I would like also to show here the current testing sites we are working currently. We are working now. We are working on testing on sea facilities on Canary Island, on North Atlantic Ocean, North Sea, and we are also testing on Italian facilities, on Spain, on harbor of Gijón, and also on Ireland, on the facilities of the company which is dedicated to manufacturing of blades. So this is all from my side, so don't hesitate to contact us if you would like to receive more information. Thank you very much.
Okay, Marta, thank you for your presentation, for summarizing all the results that MAREWIND has achieved so far. So thank you for that. Now I will be speaking you about the community of practice that we committed to build within the MAREWIND project. First of all, I think I can present myself. My name is Francisco Ngomo. I'm innovation consultant at PNO Belgium. And I've been working in innovation funded projects for 3 years now, first in the national level, Spanish national level, and now at European level. The projects I work on are mainly focused on renewable energies, hydrogen as well, and also batteries. So yeah, I think the first way to let's say start this presentation is to define what a community of practice is. Well, a community of practice is a group of people who share a common interest, profession, or passion, and engage in regular interaction to learn, share knowledge, and collaborate. Communities of practice, in the end, play a crucial role in fostering continuous learning, innovation, and the development of expertise within a specific domain. We would like to develop this community of practice with 3 main pillars that we understand that are imperative, which are, first of all, the domain, the area of interest. In this case, it will be the novel materials for increased the lifetime or the performance of offshore energies, but also the maritime sector, of course. The practice, which entails all the knowledge, methods, experiences, data that the partners, or let's say the members of this community of practice may bring in. And the third, and I think the most important of the 3, is the community itself, which basically stands for the relationships that may be built through the discussion, joint activities, and the learning that can be extracted from the community of practice. So as per MAREWIND, we established a strategy to work in this community of practice. Basically, this community of practice will be based on the key exploitable results of the project. We identified together with the partners some key exploitable results that are closer to the market. Well, in this case, these key exploitable results, they have a high TRL. So in the end, what we want to do with these key exploitable results, it's to promote the good practices, but also share them within the community, but also find a channel towards the market. Because I think that all of us that we are involved in this kind of project, what we want in the end is that this solution, reach the market. So an example of how do we want to do that is we can go for innovation initiatives with higher TRL, or also support the building with these technologies of large-scale demonstrators, or of course large-scale wind farms that actually work in normal conditions. On the other hand, we have the less mature key exploitable results, which mainly are results that are not ready to enter the market themselves. In this case, what we will enhance or boost is the creation of alternative, innovative routes or applications for these results. This can be easily achieved by new research or innovation initiatives. So in the end, this is an example of how do we want this community of practice to work in the practice. I mean, the key exploitable results, the MAREWIND key exploitable results, they aim to tackle mainly these areas, as Marta mentioned, which are materials improvement for turbines performance, corrosion, erosion, and fouling protection, predictive monitoring and modeling, and increase the recyclability of the materials. Okay, so in the end, this is a way of how the workflow should go in this community of practice. Imagine that we have two key explorable results from MAREWIND. The first one is material A with weight reduction for blades. The second one is a coating with anti-corrosion properties for C structure. So with these key exploitable results and the building of this community of practice, we might possibilities that we might find a partner stakeholder from this community of practice that has developed a novel optimized assembly process for offshore wind turbines. And in the end, these three novel approaches might raise the interest of end user, which is also engaged in the community of practice. So in the end, this is how we have in our mind that this community of practice should work. Now I'm going to give you an overview of the results of MAREWIND that we truly believe that may be key exploitable results. Sorry, because I don't know. Okay, now it's fine. In the end, these key exploitable results, they can be divided into 4 different categories. The first one is coatings, where MAREWIND partners developed anti-corrosion coatings in atmospheric and splash areas. Also anti-erosion coatings for wind turbine blades, and anti-fouling coating for metallic plastic surfaces on submerged areas. Another category is the materials, where we have nano micro containers to encapsulate self-healing materials, maintaining them during a long time. New epoxy formulation for wind blade manufacturing, which leads to reduced weight in wind turbine blades. High performance concrete for more durable offshore infrastructures even when exposed to harsh environment. Novel composites for wind blade with improved recyclability. In new elements for these turbines, we also have a new manufacturing process for lightweight wind blades, advanced materials and new design concepts for fasteners into the structures. And last but not least, in methods, guidelines, and tools, the partners have developed a model for the prediction of the structural health underwater structures to reduce the downtimes, structural health monitoring methodology for wind blades, computational models for blade performance and corrosion in offshore infrastructures, and model to predict structural behavior of composite components. In the slides, you can see this overview for the key explorable results that we think that are the most promising ones within the scope of the project. We also highlighted the partners in the project who are leading each of the results, but of course, all the consortium is working in I think all of them. So yeah. If we skip to the next one, another question that may arise is how can I, as a stakeholder, be part of the community of practice of MAREWIND Community of Practice? So it's very easy. We prepare a MAREWIND stakeholder engagement questionnaire where we will ask you about your interest in within the scope of the project, which are the key exploitable results, which are the most interesting for you. How do you think you can support or how would you like to participate in the community of practice in terms of I have a new technology that may complement any of the results that have been achieved so far in the project, or I'm interested in investing in wind turbines with the technologies you described. So yeah, you have different options there. So yeah, this is forms that we will be distributing in the end of this webinar, but we will be also promoting it through the social media in the upcoming weeks and months, probably. With that questionnaire, with that response that we obtained from your side, we will assess how your interests may result in potential synergies with MAREWIND results. We will discuss it within the consortium, but also with you, if you think that this way of collaboration may be beneficial for you. And last but not least, we also propose you to let's say to clarify how this collaboration should look like, what we have established so far, but of course we can adapt it through time and also discussing with you. It's the participation in our exploitation workshop or in our consortium meetings, so that you can suppose yeah, any experience you think is interesting for us in our meetings or in our exploitation workshop, and of course a one-to-one or let's say X-to-1 meetings with relevant MAREWIND partners. Yeah, according to your interests within the scope of the project. So now I will give you an overview of how have we planned the deployment of this community of practice. So first, we are here in this launching this community of practice with our sister projects, which are the projects which are funded in the same cold topic as MAREWIND did. This is taking place in December 2023. The next step, yeah, we will have the questionnaires open from December 2023, which is right now, till March 2024. Then we will start with analyzing the questionnaires, interests, and exploring the potential synergies within the MAREWIND project. Then from March to June, what we propose is to perform these interviews, these connections in a more, let's say, concrete way. As I mentioned, engagement in workshops, consortium meetings, one-to-one meetings, and so on. So from June 2024 till September 2024, as well, together with the community of practice members, we will try to agree in potential exploitation routes, which you think, together with the partners that are interesting to explore beyond the MAREWIND project. And the project will be finishing in 2024. So now we are planning to have a final MAREWIND event. We still need to determine where and when it's going to take place, but yeah, if you follow us in the social media, you will keep up. Will keep up with the news we will have on behalf of this final event as well with the community of practice. So I want to end this, to finish this presentation, encouraging you to join this exciting challenge, to connect and bring together all the stakeholders in this wide community. And as Marta also suggested, I strongly recommend you that you follow us in LinkedIn, so that you can keep track on our project status and the community of practice milestones. And of course, if you need further clarification, or you still have some doubts, you can contact either me or Marta, which we will be in charge of this part of the project. So we will be more than glad to receive your requests. Okay, so I will kindly request that all the speakers, you activate your camera and microphone if possible, please. Okay. Now, as mentioned, we will jump into the open discussion. In this open discussion, I will try, not I will try, I will address some questions to the speakers regarding the presentations they made, and also future challenges that they may foresee within the sector. So yeah, I would like to start with a general question. Probably I will address it to FYBERGY project. So Fabian, in your presentation, you highlighted that besides of the project partners, you participated as well with several stakeholders that were not, let's say, project partners themselves. So I would like to know which kind of collaboration could you establish with these stakeholders, or how did they participate in the FYBERGY project?
Yeah, sure. So we had two bodies. We had the standardization committee with the three standardization societies, which only one was a funded partner, where we tried to talk about the guidelines in regard of the certification and standardization of the use of FRP in maritime offshore applications. And then we had also the advisory board with a number of different partners um, acting as an advisory board. So we were presenting our results, talking about our challenges, and trying to interact with those. And we also tried to have a lot of industry partners close to the project consortium in order to just always show the industrial relevance, especially with talking about those large scale demonstrators or 3-scale demonstrators. We wanted to see if this manufacturing technologies and the parts we've developed there are relevant for the offshore industry.
Okay. Yeah, I think it's actually I think it's very interesting to establish valuable yeah, let's say partnership relations within this kind of projects. Actually, in MAREWIND we have as a project partner EWF, which is supporting with the standardization activities. So it's something that we are taking care of because we truly believe that it's very interesting thing to do, especially in projects with high TRLs as these ones. I don't know if for Carbo4Power project you have a similar approach. You have been working in this kind of activities, or
Yes, this is something I also wanted to add. We are also having an offshore board that we are doing meetings and update them on our current status and development. So we have an offshore economical board in which also EDF is participating in this board, and we have feedback. For us is very important because we are developing materials, and we are in a TRL of 6. So we still have more information for our developments for reaching in the next stage for real scale applications. And also regarding the standardization activities, we also have a specific task in which is the communication, the engagement with standardization committees, and we have partners involved in our project that they're active in standardization committees and give us valuable feedback on our developments based on these standards. And of course, also there is the mapping of all the standards that are being used in the offshore technology sectors in which we are employing in our investigation in testing and intermediate level evaluation to be in aligned with the demonstrators that we're going to manufacture.
okay, yeah, it's quite interesting as well. Also, yeah, to keep on with you with Carbo4Power project. You were mentioning that yeah, about large scale applications. So I mean, in your presentation, like, can you provide us a bit more of detail about the demo sites you are planning in the project? Like, I don't know, the location, how long are they planned to run, or any specific information you could share?
Yes, for the demonstrators, as they are for the wind turbine blade specifically, is a scale down. So it is foreseen to go for testing in a facility in Nantes. The testing will be performed by our partner, ILT Jules Verne, in a machine that is being designed specifically for scale down testing. Of course, it can also fit real scale because our other demonstrator for the tidal is in scale 1 and truncated. So we can both assess mechanically the demonstrators. And also, in our case, there is no real application, let's say, that commissioning in offshore in the sea. However, we want to assess also the structural health monitoring concept during this testing that we are investigating and aligning with the Internet of Things and machine learning. The testing is foreseen to be performed in the second trimester of 2024. And we're now finalizing the details for the testing parameters.
Okay. 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 Now probably I can address a question for MAREWIND project. In this case, to Marta. I mean, For me, it's also, I mean, because I think all the projects are dealing with this stuff, but in the case of MAREWIND, I think it's even more important because we are working a lot of with coatings and a lot of different chemical substances. So yeah, we know that one of the expected impacts of MAREWIND is in general of these projects is to a reduction of the environmental impact by 35%. Yeah, I mean, for MAREWIND, it's clear that mainly it would be as per carbon footprint, sorry, and also materials recycling and the quantity of raw materials needed, as you highlighted in your presentation. But I think that there is an issue that may be interesting also for the rest of the projects as well. What do you think about the potential interaction of these coatings or these new structures we're working on? What kind of interaction they may have with the environment, with the wildlife in the sea? Is it something that it's interesting to assess as well, or do you think it's not relevant for this kind of projects?
Well, in fact, it's something that is needed to be taken into account, and it has been done up to now. All the factors influencing the environmental impact will be assessed in the final life cycle assessment, that an environmental impact assessment. But all these issues has been taken into account. For example, as mentioned in the presentation, the antifouling coatings are biocide free. We are not using any chemical compound with biocide activity. We are getting the antifouling effect with another effects, not with chemicals. So this is something that we think it's important, and we have taken into account, of course.
And as per the other projects, are you taking this into account, and how are you taking it into account?
In
Yes.
Carbo4Power project, sorry if I may, Fabian.
No, please.
Okay, so in Carbo4Power project, there is also the riblets formation, which is a microstructured surface, which are being developed for wind and tidal. For the case of the wind is for the drought reduction, but also in the tidal, it also have an anti-fouling effect. And we're also investigating fouling release coatings. So in combination with those two, we can have anti-fouling performance for that. Now we are in environmental intermediate testing. So by the end of the project, I can give more updates on this activity.
Okay.
Yeah, we have in the FYBERGY project, we have conducted several LCAs on the different demonstrators, and we have seen that the selection of the material is very essential for the ecological impact. So, for example, the use of carbon fiber reinforced polymers actually increased the ecological impact, because we only calculated until the end of production, so we didn't take into account the use phase, unfortunately, where the carbon fiber reinforced polymers have more benefits. But when, for example, when we used glass reinforced polymers for the calculation, we've actually seen a reduction of ecological impact of around 80%. So it was immense. And we didn't calculate the use phase because it's just at this point it was very hard to estimate because we didn't have any data because the demonstrator is just not there yet. But if we did calculate out the use phase, we would actually probably see similar reductions also with other materials.
Okay. Yeah, interesting to see how all of you are tackling these aspects with the LCA, especially in this case. So, I mean, I think FYBERGY project in this case is the one who will be ending the first from these three. So, I mean, since we are, yeah, as we mentioned several times, we are in a high TRL. We want to seek for this entry to the market. We are almost there, but in some cases we still some work to be done to reach that point. I would like to ask you within the project or yeah, within the project or within the partners. Are you, I mean, do you have you planned any exploitation activities? How are you going to continue with the project? It will end there. Are there conversations with stakeholders to carry this demonstrator to the market?
Yeah, so we're actually running 4 months more. We have extended the project for another 4 months, so the end will be end of April. We've done several activities on the exploitation. As all projects, we've tried to identify the key exploitable results, and the partners are still working on that to see which one are the ones we should focus on. But for Ocean, I can say that they are going further with their concept. They are currently planning a real scale um, twin semi-submersible wind power platform in the Canary Islands, so with 100-meter towers. So this is really interesting. I think they have not focused yet on the which material they're going to use for those applications, but they are definitely exploiting some of the results which we have done in FYBERGY.
Okay. And yeah, I mean, I would like you to share what have you in mind for the rest of the projects. For instance, Stefania, you want to share some insights on that behalf?
Yes, for our case, as it is still scaled down, there's still a long way and a lot of prospects to consider for the upscaling. So in our case, it's important to disseminate and exploit the current results, which is on the intermediate scale. Of course, more effort will be given after the validation of the demonstrators in order to ensure our proof of concept. And we are also having open days. I think FYBERGY also participated in our open day, which was performed in June. And we also have a final open day by the end of the project. So that would be very nice for people to participate and engage with us on those results, and of course identify and discuss the prospects for further upscaling and application for demonstrators and concepts.
Okay, okay. Sounds yeah, sounds like a good way to keep on. And how about MAREWIND project, Marta? What can you share with us on this behalf?
Okay, as you mentioned, we have 6 months more. we have 1 year by the end of the project. So, as you know, we are working on defining the key exploitable results. We have started to the dissemination of the current results with the relevant stakeholders, and well, as also as Stefania has mentioned, as soon as we have final results on validation and on sea testing, we will have more important issues and results to be shared with the final stakeholders in order to improve the exploitation of results. But we are working on it, as you know.
Yeah, indeed. I think this is a question that, of course, yeah, I think that this is something that I can ask to all of you as well. But I will start with Stefania. I mean, as we all know, I mean, this kind of projects sometimes, yeah, we have a impact that we want to achieve, but we all know as well that the research projects are not they have a lot of uncertainty. So in the end, we end up with some things that may be different, sometimes better, sometimes worse than expected. So regarding to the expected impact that you highlighted in the presentation, could you share with us some highlights on how do you think Carbo for Power finally went differently from this expected income? For instance, something that has performed better than expected, or worse, or different, just different. Can you share with us a bit of insight on that?
Yes, I can say that at this stage it's very difficult to identify exactly the deviations for the final targets of the project. However, I can say that for the targets presented in our slides, we are actually very close, and there was a techno-economical assessment based on the advanced manufacturing processes that's we are using, and indeed there was a reduction of the levelized cost of energy below the 40%, and also for the tidal case, there was identification that there was a 35% in scrap reduction during manufacturing, and for 35% to 10, sorry. And also there is a reduced labor by 20%. These are the main outcomes of course, this techno-economical assessment for the manufacturing. And also for the wind turbine blade, there was also electricity consumption reduction from 8% to 3%. So I can say that as we are now in finalizing the intermediate investigation of our developments, the results so far seem very promising on the targets that we have set. So it still remains to see by the end of the project the final targets and how close or not close we are from them. But the initial results are promising.
Yeah, indeed. I mean, it seemed very promising, especially because, if I'm not mistaken, you still have 1 year to go.
Exactly, yes.
Okay. So yeah, I mean, this is very promising indeed.
Yeah, we
Yeah.
have had similar experiences. So with for example, also the cost-benefit analysis, it largely depends on what fiber you were using for the calculation. So as I mentioned briefly before with the LCA, the carbon fibers not only have a very high ecological impact, they're also very expensive. So if we did the calculations with the carbon fibers, we actually had an increase also in the cost. But so we could adapt and change the materials to reach the impact we were looking for. But so yeah, sometimes it's very difficult to really reach the goals you put in the proposal. It's a tough thing.
In our case, I can say that we define the procedure in order to assess the final results in contrast with the targets. We can say that up to now we have get the target according to the individual improvements of materials, but we have no results up to now according to the reduction of the leverage cost of energy, which is the final results of the project. So we will see. As mentioned, for all of us, results are promising, but we have not the final results of the impact.
Okay. I would like to raise another question, because I think that for all the renewable energies that I mean, we are in innovation projects, we know that the technology is advancing at a extremely fast speeds right now. So what we can see that it probably it's happening or can happen in the next years is that in the end, right now, the repowering opportunities for aging wind farms or other kinds of energy are really attractive to investors when they have really old wind farms. So probably I can address this question to MAREWIND. I mean, with all these innovation projects we are working on, how can we fight? Because in the end, all this dismantling of wind farms may produce a lot of waste. Also, it's a practice that is not really good, I think, for the environment. I mean, we are building a sustainable solution, but in the other hand, more technologies are being produced. So how does MAREWIND or the results of MAREWIND can help to ensure a sustainable value chain in this sense regarding the dismantling?
Well, in the case of MAREWIND, we have some activities related with recyclability of the composite of the blades, but they are small and specific activities. I think that the most important thing in this case is to have the involvement of all the partners of covering all the value chains of the sector, and that's a good view in order to involve also the recyclability and the final impacts, let's say, of this kind of activities and facilities.
Okay, and what do you think the rest of the project? What do you think, or your project, or how do you envisage the future in this on this behalf?
Yeah, so FYBERGY, we also did recycling and waste management guidelines, but we focused mainly on the production waste, since it's very hard to estimate 20, 30 years into the future what kind of recycling possibilities there are for this kind of materials and products. So there's definitely the need to develop appropriate recycling solutions for fiber-reinforced polymers. But yeah, it was just not the main goal of our project.
And how about Carbo4Power? Any insights? I think that this part of the project is a small one as the rest of the project, but if you have any specific idea or any insight you would like to share.
Yes, for our case, we have a dedicated task which is related to the decommissioning and recycling strategies and frameworks. So for us, it is an ongoing activity to identify what is the current status for all the commissioning and decommissioning of the blades, because we're focusing on the wind and tidal blades of all the structure, and also do a correlation with our technologies for this type of activities, because we also have the material that has a dynamic nature for the resin. We're investigating solutions for debonding on demand, so that would be easier to debond the part that needs maintenance or to be replaced. So this is why we're also investigating the modular concept for the wind blade, and also the functionally graded adhesive to close the loop. So we have the composites, the glass fiber composites that they're used for the blades, which we recycle, and then we valorize and make the functionally graded adhesive carriers. So we have like reintroduction of the materials through the recycling technologies. So we are investigating this, and we're also having a respective deliverable, which is also public, where we will further elaborate on this activity.
Okay, yeah, I think it's interesting that you also, like the other projects, you also included this task about the commissioning. It's very, very interesting because in the end, it will be a future problem that it must to be faced anytime. And also, I would like to this question maybe is only for Carbo for Power, because probably in the presentation it wasn't very clear, at least for me. Like, could you explain, because you mentioned that the materials you're working on can be, I mean, are meant to be used in tidal turbines and also wind turbines. So what I mean, if there, I mean, I guess that there are some difference there. So in the end, which are the main differences that we must highlight on these two approaches?
Yes, there are some differences because there are different blades. So for the wind turbine blades, we have hybrid reinforcements. So for the wind blades, we're also using not only glass fibers, but also carbon fibers in the form of pre-pregs. Also, we have this debonding on demand concept for the modularity, and of course specific coatings that are being applied for specific functionalities, such as the protection from erosion in the leading edge, that we have the de-icing and also anti-icing functionalities, and for the tidal also to have fouling release, we will have a full carbon demonstrator. So the materials that they're not very different, but they're specific material specific areas for specific functionalities for each case of the demonstrators.
Okay. Okay. Perfect. Perfect. Okay, I think that yeah, I think that we don't have any question for the audience. So I think we discussed all the topics that can be interesting for all the projects. I just want to remind you that we will have for this community of practice, where we will have I think workshops similar as this one, not with the project's presentation, of course, but more to discuss what the different stakeholders have developed so far, what experience do we have, and how can we walk towards shared learning. So yeah, we will have this questionnaire available. We will share it in this chat, but we will be promoting it through social media quite a lot. So yeah, so that you don't miss the opportunity. Also, I would like to thank you, all the speakers, to this interesting insight you gave about the projects. Also, to the audience who listened to us. And yeah, I think we can close this webinar. Have a nice day, all of you.
Thanks for the
Thank
organization.
Thank you. Thank you for
Francisco.
having us.
Ciao.
Thank you very much.
Thank you. Bye.
Have a nice day. Bye.